Hello everyone, welcome to this video on Thevenin equivalent circuits. So what are Thevenin equivalent circuits? A Thevenin equivalent circuit can be seen as a simplified circuit, which is the one that you can see on the right hand side, simplified from a more complex looking circuit on the left hand side. So this is a way in which we would like to simplify circuits to result in a single voltage source, VTH, a single resistor, RTH, and a load resistor value, which is the same value as that which was on the more complex circuit. Now, what is VTH? VTH is your Thevenin equivalent voltage, which is defined as the maximum voltage across the load resistor, while RTH is your Thevenin equivalent resistance, which is also known as the resistance looking into the circuit from the load terminals. So if we take a look at an example where I have a 10 volt source, an 8 ohm resistor, and a 2 ohm resistor, and I would like to determine the relationship between the voltage across the load resistor, if we call this the load resistor, and the voltage across the load resistor. So I would like to determine the relationship between the voltage across the load resistor and the load resistor itself. So if I were to determine the voltage there, VL, if I use voltage division, it's going to give me 2 over 2 plus 8 multiplied by 10, and that's going to give me 2 volts. So when the resistor is 2 ohms, the voltage is 2 volts. How about if I change this just to determine what the relationship will be? So if I make this 8 ohms, so I increase the load resistor value, what will happen? The voltage VL was going to give me 8 over 8 plus 2 times 10, which gives me 8 volts. So when the load resistance is 8 ohms, the load voltage is 8 volts. So what does this tell us? It tells us that as the resistance value of the load increases, so too does the voltage across the load. We defined VTH as the maximum voltage over the load resistor. So what would we have to do with this? To get the maximum voltage over the load resistor, we would have to ensure that the load resistance is as high as possible. So in order for us to do this, this circuit has to then be replaced by a circuit where the resistance is as high as possible. And what is an equivalent resistance that is as high as possible? The load resistor must then be replaced with a value which is high, infinity, which in electrical terms would be an open circuit. So the circuit then becomes a voltage source, a resistor, and an open circuit. And we are now looking for that voltage VL, which in this case will now give us VTH, because the load resistor has been replaced with the open circuit. Will this be the maximum voltage of the circuit? Surely it must be, because I've got a 10 volt source there, and know the voltage here is 0 volts. It will increase by 10 volts. That will be sitting on positive 10 volts there. The voltage here, voltage drop across this resistor, must be 0 volts because the current flowing through here is 0. That means the voltage at this point will still be 10 volts. Therefore, VTH, if I call this A and B, VTH, which is V from point A to point B, which can also be seen as VA minus VB, is going to give me 10 minus 0, which then gives me 10 volts. And we can see that that is the largest value of the values that we calculated. So how do we find the Thevenin equivalent resistance? First we detach the load resistor that is connected to the circuit. Second, we deactivate all independent sources. So what does this mean? The voltage source or voltage sources will become short circuits, and your current sources will become open circuits. Finally, you find the equivalent resistance looking in from the two output terminals. What about the Thevenin equivalent voltage? So to find VTH, first we disconnect the load resistor and replace it with an open circuit. So we'll remember that step from the previous slide. We have to make sure that we replace the load with an open circuit which has R equals infinity, which will result in the maximum voltage, which is VTH. Next, we will determine the Thevenin equivalent voltage through activating the sources again. And activating the sources means the short circuit then becomes a voltage source and the open circuit would become a current source. Finally, we will find the equivalent voltage across the terminals. That equivalent voltage, VTH, would be VAB, which is VA minus VB. This value will be found, and that will be your Thevenin equivalent voltage. Thank you for watching this video, and enjoy the course.